All right. Good morning, everyone. My name is Travis Clayton. I'm the National Sales Manager for LFSystems, and thanks for joining us for our second weekly webinar. Hope some of you were able to attend the one last week. It was a great success, and we want to keep on doing that. So today we are going to talk a little bit about laundry exhaust and makeup air. LFSystems is another brand that's also part of RM Manifold Group. Just like USDraft is a brand of RM Manifold Group, LFSystems, different brand, same company. If you do have any questions today, there is a Q&A box. Please feel free to submit any questions through that Q&A box. Jason is online right now. He is going to be answering those questions as we go through the presentation. So share your questions in there, and we'll get going. So LFSystems is formerly known as Laundry Fab. We recently announced that we were going to kind of rebrand to LFSystems just because we started doing a lot more than laundry and dryer exhaust with high-rise exhaust, bathroom exhaust, and then we have some new systems that are going to be aimed at high-rise fire and smoke control and prevention as well. Today we're going to learn a little bit about laundry exhaust and makeup air, commercial and multi-story applications. First, we'll kind of talk about high-rise systems. We'll talk about subduct risers and prefabricated shafts, and then I'll switch gears and we'll talk about laundry exhaust systems and supply and makeup air. So first off, there are two basic types of dryers. Your type 1 dryers are your domestic dryers you have at home in residential, in high-rise apartments, condos, homes as well. Type 2 dryers are your commercial dryers that you have in laundromats, gyms, health clubs, hotels, hospitals. Basically, when you have a bunch of dryers in a bank, actually, even if you put multiple residential dryers that are sold as residential dryers in a bank and are common venting them, type 2 code will actually apply to those dryers. So first, let's talk a little bit. Here we go. So about some basic requirements on these dryers. The most typically the biggest requirement we're trying to get around is the maximum equivalent feet of exhaust duct. Under IMC, your type 1 dryers can have no more than 35 equivalent feet of exhaust duct, and each 90-degree elbow is actually 5 equivalent feet. UMC is a little different. If you have a project in a UMC area, it is 14 equivalent feet, but that includes 2 90-degree elbows. But a main exception there is if the dryer's manufacturer's installation instructions say to do something different, please, by all means, do what the manufacturer says to do. Of course, the code on type 2 dryers is not quite as specific. The code basically says you need to do what the manufacturer tells you to do. The other thing to note is these dryers, they're actually typically designed to run with a little bit of positive pressure at the outlet. Your type 1 dryers between 1/10 and 9/10 of an inch, while the type 2 dryers 1/10 and 1/2 inch, a little bit more narrow range there. So where does that 35 equivalent feet come from? So when you have a dryer that's a 200 CFM dryer, that's 200 CFM completely unloaded with 0 foot of exhaust duct. So when loaded dryer, that's kind of what the blue curve represents, is your loaded dryer. And we kind of found, just general rule of thumb, it's going to take about 100 CFM to dry your laundry in one cycle. Beyond that, your underwear might be dry, but your jeans and towels is probably going to take more than one cycle, and it's going to start to become very inefficient. So where does that green line cross that blue line? Right there at about 35 feet. And that's kind of where the code originated from. So here's the actual code reference for IMC. Of course, 35 equivalent feet. Each 90-degree elbow is 5 equivalent feet. Main exception here is, of course, if the manufacturer's installation instructions say to do something different, please do whatever the manufacturer says to do. Here is your UNC code reference. Just like I said, a little bit different. Each 14 equivalent feet, including 290. Main exception here, they also have an exception for those inline power venters, DPD, VD power venters. Just keep in mind when you see those are only listed for individually vented type 1 dryers. You cannot use them on anything common vented or any commercial dryers because the motor is located within the airstream. And I'll go over a little bit more of that code here in just a moment. So first, let's talk a little bit about type 1 dryers. I'm sure if you live in the city, you drive around today and you see a lot of multifamily construction going up, a lot of high rise. So what's, whether you're venting your dryers or your bathrooms, of course, the easiest, cheapest way to do is natural venting out your sidewall. But, there are some reasons why you might not want to, or you can't always do that. Of course, you've got all these sidewall penetrations on your nice glass facade. You could be sitting out on your patio in this picture and it's blowing, hot dryer exhaust or stinky bathroom exhaust on you. It's just not, a pleasant, situation. You have all these wall penetrations. Picture on the right, I'm not sure who would do that, but of course those people in the middle are going to exceed that 35 feet. They're going to have some venting problems there. Another consideration we have is wind gradients. So a 7-mile-an-hour wind near the top of a 15-story building can actually create up to 0.92 inch of static pressure. So if we remember a couple of slides back, that range those type 1 dryers operate in, 1/10 to 9/10 of an inch, that's going to exceed that range. And now the guy who pays the most for his condo up at the top of the building is not going to be too happy because his dryer is not going to be able to exhaust. So then on the leeward side, now conversely, we have the opposite problem. So now we're pulling a negative, and now we're pulling a bunch of conditioned air out of those off appliances and dumping it outside. Although, if you're drying your clothes, it'll probably vent well, but you have to be careful there because that negative pressure can actually suck the flame off the burner of that dryer and put your clothes on the crispy cycle, which is bad. So that's one of the reasons why the AIA recommends minimizing sidewall penetrations and going through the roof. And then another issue we deal with is just the floor plan. So when the architect designs that floor plan, he's typically not going to put your washer and dryer anywhere near that sidewall, right? So we see in these two floor plans here that sidewall is their nice facade, all their windows, kind of the prime real estate of that apartment. So the dryers always typically get put towards the inside of the floor plan. So now, by the time your 290s and out to that sidewall, you've exceeded that 35 feet, and you're going to be violating code and having some venting issues. So a lot of times, what we have to do, what a lot of these high rises do, is they common vent these dryers into a shaft system. So there's a little bit of code I want to touch on these shaft systems to be aware of. Of course, first off, these shafts, they do have to have a 2-hour fire rating as required by International Building Code. And also, I'll kind of talk about a little bit about the differences between a dryer shaft and like your bathroom shafts or domestic kitchen exhaust shaft. So fire and smoke dampers, they are prohibited in a dryer exhaust shaft because fire and smoke dampers, they collect lint. Lint is a fire hazard. So in this diagram here, that's why you have to have these little subducts that go into the shaft and turn up 22 inches that basically prevent smoke from going back down into another apartment. And I'll talk a little bit more about subducts here in just a moment. Now, you can't have offsets in the shaft. The shaft needs to be straight until you get to the roof line. The fan motors, they do need to be located outside of the airstream. Like I said earlier, the fan motors inside the airstream, they can collect lint and get hot, and it's a fire hazard. So for code, motor must be located outside the airstream, and that exhaust fan needs to run continuously. And now by code, it actually has to be connected to standby power as well. So This is where variable speed fans really come in, really important. Of course, with the cheap constant speed belt driven fan, if you put one of those on there, now when those appliances aren't running, you're pulling a deep negative in that shaft, and you're pulling a lot of conditioned air out of those off appliances and just dumping it outside, which is really inefficient. And you'll have to have a means for supply air for that air to come from somewhere, and so you could put a relief damper in the bottom, but depending on where that is, that could also be conditioned air as well. So it's a very inefficient system. What we recommend doing is always using a variable speed fan. Our system, the way it works, we put a pressure sensor at the near the bottom of that shaft and modulate the speed of the fan to hold a slight negative, in that shaft. And when those dryers ramp up, we sense that change in pressure, ramp up our fan, hold that slight negative. When they're not firing, we ramp our fan all the way down to where it's just barely going, just enough to meet code, but not enough to really be pulling a bunch of conditioned air out of those appliances and dumping it outside. So it's a far more efficient system. That fan controller, per code, it has to be in an accessible location, and it has to have an audible or visible alarm signal whenever the fan is not in operation. Like I did mention, you do have to have makeup air for the exhaust system. A lot of times they will put in a relief damper near the bottom. You actually do have to have a clean out in the bottom as well, because any vertical rise, that shaft, lint and particulate will fall out of that vertical rise. Now, bird screens. You can't have bird screens or finger guards on the termination of a dryer exhaust shaft, because that also collects lint. It is a fire hazard. Of course, there is no lint in a bathroom exhaust shaft. You can terminate with a bird screen, but for dryer exhaust, we always recommend a gooseneck termination when you're going to the roof, because it does not have any bird screens or finger guards. And then, of course, lastly, these shaft systems, they have to be independent of other systems. So you can't common venture dryer exhaust with your bathroom exhaust. Those need to be separate shafts. So this is some of the equipment we use. This is one of the fans we use. It's a multi-use exhaust fan. We've been using it for several years. It's been a great fan. It's a true inline 90-degree fan, variable speed fan, and we use EC motors on this up to 1 horsepower. And we've got 10 sizes available, all the way up to 16,000 CFM. It's listed to be installed indoors, outdoors. It is a spark-resistant aluminum, and it's UL listed 378 up to 350 degrees continuous. Now, it's been a really great fan for us, but we recently came out with a new fan. The DEF dynamic exhaust fan. It's a similar fan, but it does have a few improvements. Main thing here is it has a removable access door on the side. So when you do have to clean out your fan, you don't have to take the plug out and the motor and impeller, which is kind of a pain. I know on the competitors, that little hinge on that motor tends to break a lot. So we figured it was a lot easier to add a little access door on the side. So all you have to do is hit your disconnect switch, take off that access door, and you can clean out your fan without having to remove the motor and impeller and plug and everything. So this is a great fan. Also, UL 378 and 705. It's got a little bit of a higher temperature rating on this. We've got 8 sizes up to 7,500 CFM on that. Beyond those larger fans, we're still using the MEF style fan. Motors. These fans, we typically like to use EC motors on this fan. We're using EC motors up to 1 horsepower. The larger fans, beyond that, we use induction motors. It's with 10-to-1 turn down ratio on these motors. Great thing about those is they are available off the shelf. So if your fan goes out on 5 o'clock on Friday, you don't have to wait till Monday for us to order one from us to ship you one. You can actually go get one off the shelf at Granger. This is a controller that operates this system, the L150 controller. It's a new controller as well. We recently moved from the L100 to the L150 just because it was a more customizable, easier to use, a better controller. It works with the 5, the little black thing you see there. It kind of looks like a breathalyzer. It's a bidirectional pressure transducer. Measures all the way across 0, positive to negative, 1 inch, accurate to a 100th of an inch. This is a great controller, very easy to use. All the set points are programmable in the field if we need to adjust anything to meet the needs of a unique system. So why do we need a bidirectional pressure transducer? I know Jason talked a little bit about this last week. If you were there for that presentation, of course, while that's extremely important for boilers, it's also important for dryers because we're holding a slight negative in that shaft or in that comment, negative 1/10 of an inch. So a lot of I know that a lot of the competitors out there, their transducers might only read negative or positive. So one of them only reads negative, neutral to negative 0.6. So if we're holding a slight negative in that shaft and a dryer or two ramps up, we're going to briefly go positive. So we're actually able to read that change rather than reading it as neutral, which does allow us to react to changes much faster than any other system on the market. So you know, gives you a little range on either side, rather kind of like than pegging your speedometer at 80 miles an hour. Gives you some range, so you know exactly what your true pressure is. So let's talk a little bit about International Building Code. So International Building Code says that on these shaft systems, you need to have fire and smoke dampers. Now, wait a minute. We know under International Mechanical Code, we can't have those in a dryer shaft, right? So here is the exception. Here's where we start to get into subducts. So you don't need those fire dampers under International Building Code when you have those exhaust subducts inside the shaft that extend up at least 22 inches. And you don't need fire and smoke dampers when you have those 22-inch subducts with an exhaust fan at the upward termination of the shaft that is powered continuously. So traditionally, subducts were these field fabricated subducts were these big round things that go in your shaft and come up. As you can see in that picture on the left side, is that they take up a lot of space, and you got to calculate for that when you're sizing that shaft. So as you can see on the pictures on the right, those you know, I can see all the way to the bottom of that shaft. So just by using low profile subducts, under one example, we were able to reduce the size of that shaft by up to 52%, which is going to save a lot of space as well as a lot of money in the cost of that shaft. So this is kind of what they look like. They're super easy to install. They're also a lot easier to install than a field fabricated subduct. They just very low profile design, kind of fits right in there, right along the side of that shaft. Right now, we offer sizes from 4 to 10 inch. So this is how do you get that 2-hour fire rating in the field? You know, this is a conventional dryer shaft, even with those prefabricated subducts. In order to get a 2-hour fire rating, you've got to have your smooth, rigid metal interior of that shaft, 2 layers of 1/2-inch sheetrock, your 4-inch stud cavity, and 2 more layers of 1/2-inch sheetrock in order to get a 2-hour fire rating. That's a lot of materials and a lot of labor. It takes up a lot of space. It's a pain. It's multiple trades, multiple inspections, minimal warranty. You know, it's expensive. That's one of the biggest complaints about shaft systems. So you know, we've tried to address all these concerns as best we can, and we've come out with a prefabricated shaft system with a UL listed 2-hour fire rating. It's actually 0 clearance combustibles. So this is great for dryer exhaust. We also sell it for your kitchen exhaust and domestic kitchen exhaust and your bathroom exhaust. It does come in a fire rated double wall configuration as well as a single wall configuration. The subducts are integrated, already built in. You can see kind of in this picture in the top left that little cord that runs across the bottom is actually a subduct. And they're super easy to install here. It's actually, to put them together, it's a simple flange to flange V-band connection. So it can be put together by an apprentice you don't need expensive welders to put this thing together. We can do up to 4 taps in a section, 4, 6, 8-inch taps, anywhere from 8 to 36-inch inner diameters. It is going to reduce your footprint as well. Of course, on that field fabricated shaft, you're plus 6 inches on all sides in order to get that 2-hour fire rating. On a prefabricated shaft, you're plus 3 inches. And we've actually found this round shape to be the most efficient shape, because on the square you tend to not get a ton of flow out of those corner areas. So this is kind of what the prefabricated shaft system looks like, all said and done. So it is 0 clearance combustible, so just 1 layer of sheetrock to finish out your wall. We even had a customer, it was going through a column. They turned it, or going through a lobby, excuse me, and they turned it into a column. You can even do some kind of cool decorative things with these because they are 0 clearance combustibles. So you don't need to build a separate fire rated shaft. So versus your field fabricated shafts, this is going to save you a lot of money in materials and a lot of money in labor. It's going to reduce your footprint and increase your amount of floor space. It's going to save you time in building this, and then we can pair it with our fans, with our controls, so that you have an engineered system from one manufacturer with a limited lifetime warranty that's going to reduce your liability. So this is one trade, one inspection, one of the best, the most efficient system on the market right now. So this is brand new. We want people to know that this is available. So this, in a nutshell, that is shaft systems. Any questions on those, please type them into the Q&A box, and Jason will answer those for you. Now let's shift gears and let's talk a little bit about commercial systems, type 2 dryer systems, that what you see in laundromats, hotels, hospitals, gyms, health clubs, dormitories. Like I said earlier, even if you put residential dryers in a bank and come and vent them, type 2 code will actually apply. They at that point they become type 2 dryers. So code is very similar on type 2 dryers. Of course, no fire or smoke dampers in your type 2 exhaust duct. They are a fire hazard. They collect lint. This picture right here is actually one of the first jobs we did, and they had after the fact installed a fire and smoke damper, and the heat from that dryer had caused that damper to close, and now they had a blocked flue. So please don't use fire and smoke dampers. Of course, no bird screens at the termination, no finger guards, nothing that can collect lint at the termination. Please, we always recommend a gooseneck termination. We do offer a sidewall termination as well. We can go sidewall, but please just have common sense. Don't put your hand into a moving fan. And also beware, some manufacturers out there might tell you to, with its dryers, just take your bird screen or your finger guard off. I have to warn you against doing that, because that will actually void the UL listing on that fan. So we always recommend a gooseneck or a sidewall termination for dryers. Of course, you know, your bathroom exhaust, like I said earlier, is a little different. And of course, those dryers do need to be installed in accordance with their manufacturer's installation instructions. If they're and that includes exhaust duct length. Also, each vertical rise must have a means for clean out. Lint will drop out of those vertical rises. And no inline power ventures. This is a picture of those DPD inline booster fans that I mentioned earlier. Keep in mind these booster fans, they are only rated for type 1 individually vented dryers. So nothing type 2 and nothing common vented, because that motor within the airstream collects lint and gets hot, which is a fire hazard. Ducts, type 2 ducts shall have a minimum clearance of 6 inches to combustible materials. Transition ducts shall be limited to single lengths not to exceed 8 feet. So we designed a system that meets all this code. It's our laundry exhaust system. It's kind of a schematic of how it works. Might look similar to the boiler system you might have seen last week. So The fan here is an inline 90-degree fan. You can kind of see it down here in the corner. Where's the little pointer here? I don't know. I'll worry about that later. But that fan can actually be located anywhere downstream of the last dryer. So you could install it up there at the termination, or down here where it is, or down there where that cleanout is. Of course, we do have cleanouts at the bottom of every that vertical rise, as well as the each dryer connector. We put a cleanout at the back of the common. Also, this system has an inline lint collector, which is a really great option for these systems. It makes the fan last a whole lot longer before you have to clean it out. And I've got a slide on that in just a minute. I'll talk a little bit more about that lint collector and how it works. Of course, now this system does use the same fan and same controls that we use for our high-rise system, just a little bit different programming. Okay, and also I know Jason touched on this slide a little bit last week too, but I'll go ahead and talk about it. For dryers, we always recommend using a lateral T versus a 90-degree T, just like when you're venting boilers, because that if you tell that flue gas to go straight into a wall, it'll create a lot of turbulence in that manifold, and it'll create an air dam in that common, and it'll cause issues, not only reading the pressure of the appliances behind that one, but also exhausting those appliances as well. So we always do recommend using a lateral T. Of course, yes, a boot T is better than a lateral T, but a lateral T is really the ideal way to go. Like Jason said last week, it's more like merging onto the highway versus coming to a stop sign, which is a great analogy. So commercial system, like I said, it does use the same fan and same controls as the other system, just a little bit different set points, or a little bit different programming. Of course, in all the set points, we can adjust those in the field as needed to meet the needs of a specific system. Of course, bidirectional pressure transducer, we read all the way across 0, plus or negative 1 inch. So inline lint collector, this is a really great option to add to any commercial system, and they're actually really popular. So we've got 11 sizes available right now, up to 4,800 CFM. It's got a inline an 800 micron filter bag that comes with it, and we can even do an optional pressure switch across that lint collector. So whenever it hits a certain pressure drop, it notifies the controller, beep, beep, that it's time to change your lint bag. And it just kind of depends how often you use your dryers, what you're drying. I know in the state they change these out every shift, which is probably excessive, but you know, they are drying a lot of towels, so it's reasonable. Just kind of depends, but that's why that pressure switch is a really great option. Lets you know whenever that bag is getting full. So what about this? 4,800 CFM, that's great for small to mid-sized systems. What about large systems? If we don't want to have to put one of these on each dryer, we do offer an option for that as well. These are the AF high capacity lint filters. They go all the way up to 10,000 CFM. There's a standard or wall mount design that can be installed indoors or outdoors as well. It's a fiberglass housing, and it's a passive system as well. So you don't need any external power or compressed air to run these. 160 micron filter screen on these, and of course we can do the optional pressure switch across that lint filter as well to let you know whenever those need to be changed out as well. And then makeup air. So you may not need a ton of air for those dryers, but you do need a lot of air for those dryers to actually dry your clothes, right? So that air has to come from somewhere. By code, anything more than 200 CFM, which is basically anything more than one dryer, has to be provided with makeup air. So you do have a couple options for makeup air. One option, you can use louver, but there are some issues with louvers here. You do have a very large ball penetration that's not load bearing, and could even have some security issues if someone were to pry that thing open. Also probably not the most aesthetically pleasing solution here. You got a louver here with some conduit going into it, so And then, you know, these louvers also, they tend to be very undersized for, especially for dryers. You know, a lot of times makeup air tends to be forgotten about for dryers. So in these louvers, when you size these louvers, they have a certain amount of free space that you got to calculate for. So like the big louver on the left is going to have more free space than the little door louver on the right. So if you're, you know, undersizing your louver, like, oh, we'll just use this little door louver, it's going to be not sufficient, and it's going to pull the room into a deep negative whenever those dryers are running, and, you know, which is going to cause those dryers to also run inefficiently. So another option you have is a supply air system, Spire Fan, which is a really great option. It's actually works to the same controller, same fan. We do offer a inline straight through fan as well for supply air. A couple advantages to using, you know, a supply air system over louvers is, well, first off, it provides only the amount of air needed. So air in, it's bringing exactly the amount of air in that is being exhausted based on our pressure sensors. Also, you're going to have a much smaller wall penetration. So we had a job, just for an example, this job had 10 200 CFM dryers. We had calculated that they needed a 4-foot louver in order to supply enough air for those dryers. However, if they use a supply air fan, they only needed a 12-inch wall penetration versus a 4-foot louver. So much smaller wall penetration. And then finally, cost. So I know a lot of people kind of shy away from this, thinking that a Spire system is going to be a lot more expensive than a louver, but you'll actually find it's pretty much very competitive in cost. So and one of the reasons being is that our controllers will actually run the Spire system as well as the exhaust system, one controller. So this is actually the national spec here for 24-hour fitness. It's one control unit right there. I know it says L100. We're using the L150 now, old controller. It's one control unit running both the exhaust fan and the Spire fan. It works with 2 pressure transducers. So the supply pressure transducer is open the outside and open the room, while the exhaust pressure transducer is open the room and open to the common. Of course, this little system here has 4 dryers. Got our 45-degree lateral T's here. And then so ducts. We also offer ducts to offer a complete system from one manufacturer. Great thing about these is they fit together with simple over the joint, like V-band connection. You don't need any tools either. It's just a kind of a latch, which makes it incredibly easy to put together. Also, it makes each section a clean out. So all you have to do to clean out your system, just pop your bands off, pop your section out, clean it out, and pop it back in, and you're good to go. So gives you a lot of flexibility there. And then calculations. So we actually help size these systems for you and run calculations for you to make your job easier and reduce y'all's liability. So when we calculate, when we size a system and select a fan, we do use diversity factors. Of course, as a general rule of thumb, the more dryers you have in that system, a lower diversity factor you can use. These are the recommended ones that we use for high rise. However, you know, of course, if there's a particular diversity factor you want us to use, just let us know. We can figure all that stuff out. And, you know, of course, then we're going to give you a copy of your calculations to see why you did, how we did, and what we did it. So just to reduce your liability, we've got a fantastic team of engineers that stands behind us. Timothy McNulty, he's our co-founder, kind of serves as director of engineering, designs all our products. It sits on a ton of code councils, ASHRAE boards, and things like that. Is very involved in the code. And Zach Johnson, if you've ever worked with him, he's fantastic. We do try and get all our quotes and engineering requests back in as fast as we can. So great team of engineers that stand behind our systems and help design. That'll help you out in the design process. So, in a nutshell, that is laundry. So, like I said, at LFSystems, we kind of rebranded that because we started doing more than just dryers. I know right now I will mention a couple other things we do, and we hope to have we will soon have this will be a whole nother presentation that we'll throw on our schedule. So whenever we do, make sure you sign up for that one. I know in this kind of right now with the pandemic going on and everything, and everyone working remotely, we wanted to see, how we can best help the situation. And we have this one controller. I'm going to mention that the VRX is it has an integrated transducer that reads accurate to actually 1/1000th of an inch. So it makes it great for room isolation systems in hospitals where people with highly infectious diseases such as COVID-19 are isolated, and it'll monitor the pressure in this room to hold it at a slight negative. So whenever a door is opened, it'll prevent contaminated air from escaping through those openings. We can also do the exact opposite with a stairwell pressurization system for fire control. There will be more to that hopefully soon. Whenever that presentation becomes available, please make sure and sign up. That'll be a great one. Of course, our other lines, I will mention USDraft. I know Jason talked a lot about that. I won't talk too much about this because Jason talked a lot about it last week. USDraft was our first brand. We actually originally used to do laundry fab or laundry under USDraft, but not everyone knew that USDraft did laundry, and it was kind of time to kick laundry out of its nest to become its own brand. So. Of course, USDraft is focused on boiler venting. All their products are made out of 316L stainless steel to resist condensate. Of course, they're controlled more because boilers are quite a bit pickier than dryers typically. And then lastly, KW USA is Kuster & Weber. KW USA is the American division of Kuster & Weber. And we're the exclusive U.S. distributor for them. Kuster & Weber is a German company over in Germany. They're actually very well established over there. Been around over 80 years. But they're very new to the U.S. Only been in the U.S. about 8 years. One of the best-selling products there is this on the left side, that little RSD stainless steel exhaust fan. So it's listed up to 1,000 degrees, and it's we sell a lot for hearth, but it also has a because it is that blast. We sell a lot for it has a grease rating on it too. So we sell it for like little pizza ovens, coffee roasters, brew kettles, kind of some unique things like that. 3 sizes up to 2100 CFM. KW also has a couple other unique things: stainless steel barometric dampers, on-off flue dampers. And we're going to have an electrostatic particle separator or electrostatic precipitator this year too, which is going to be really exciting. So that's my short little presentation. Thank you so much, everyone, for joining. If you have any other questions, feel free to email me or Jason or Zach. We're all here to help you guys. And next week we're going to have Jason is going to be back doing a combustion air presentation. We're going to get that link out to you guys shortly, and for CEUs we'll be getting those out today and tomorrow as well. So thanks again for joining us.
Real quick, Travis, I'm going to jump in. We've had a lot of great questions, so I'm going to go ahead and read a few of these.
Please do.
Make sure that the group was able to see them. The one question I kept getting was, can we get a copy of the PowerPoint? Absolutely. We can send out a PDF. If you send either Travis or I an email, we can get you a copy of that. I know a few of you have put your emails here in the Q&A, so we can. I've got those listed. But if you have anyone that didn't get on that list, go ahead and shoot me a shoot one of us an email. As far as the actual presentations, there was a couple of questions about lint traps or any way to clean out a lint system on the prefabricated shaft system. We actually have a couple of different ways we can do that. Most of the time we design the system to where the velocity is low enough that that lint will fall out of the airstream to the base, and then we'll have an access door or a T-cap or some kind of an access, some way to access the base to clean that out. A couple different questions about diversity. As Travis mentioned, we do have a kind of rule of thumb, but diversity is really dependent on your system. It depends on, you know, obviously you and your owners are going to have a better idea of how it's going to be run. If you plan on only running 80% of the system, so be it. Again, depending on the type of building it is, depending on the type of application it is, will determine that diversity factor, and we can work with you on that. Also, like Travis mentioned, we provide design assistance both for the fans, shafts, commercial systems. We size the duct for you. We assist you completely with the sizing of that. The question came up a couple times about the sensor location on a commercial system, about where to put the pressure sensor. And the reason why we have the sensor between the dryers and the filter is that we can actually see that a full loaded filter will actually create more pressure drop for the fan. So therefore it's going to ramp the fan up because we're trying to pull through that lint collector. If the sensor was on the downstream side of the filter, we would not see that back pressure at the fan. So it wouldn't be able to compensate for it. So that's the reason for that. We also have the option of putting a secondary pressure sensor across the filter so that it will alarm and tell you that we've exceeded the pressure drop across that, and it should be serviced. And then a few questions, last couple things. For makeup air systems, there was questions about conditioning the air and heating coils for extreme conditions. We absolutely can work with you on that if you're in the you know, up in the Northeast. Up in Canada, I know we get this question a lot about heating coils. We can absolutely assist through that and size for that. You know, we can provide the coil. We can assist you in finding your own coils, again, depending on your situation. So handful of other questions came in. It looks like most of them are about the PowerPoint. So that's pretty much all I've got, Travis. If there's anything you want to jump in with, otherwise we're good to go.
Yeah, I think that's good. Thanks everybody for tuning, and make sure and sign up next week for Combustion Air.